Okay, so now we're getting into a bit of a trickier example where we've got to find the angle between I plus j and 2i plus 4j. Now, get a pen. So, how are we going to do this? Well, it's probably worth, if it's tricky, draw a picky, right? So, we can have one up, one across, and that could be, I don't know, some point A in the plane maybe from the origin. So we have this sort of vector going on. So this is a position vector OA, which is given by the vector I plus j. Okay, cool. Now we've got 2 in the I direction and 4 up here. So point V is somewhere up here. So your vector OB is going to be 2 in the I plus 4 in the j. And we want to find what A to B is. Well, we just do B minus A. So A to B is OB minus OA, one of those key little formula you need to remember. So we just do B take away A there. So we've got I plus 3j. And we need to find the modulus of each of these. So we can do mod OA. Well, that's going to be, what, the square root of 2. And then we've got mod OB, which is going to be 4 plus 16 root 20, which is 2 root 5. And then we want the modulus of A to B, which we can now do, that's going to be 1, that's going to be 9, that's going to be 10. So, we've got all the lengths we need. All we now need to do is apply the cosine rule, because this is just a triangle, right? So we want cosine of the angle, what we're after, and then we're just going to apply the cosine rule to it. We've got this length and this length, so O to A is, well, let's give these some names, I guess. So we'll call that A, we'll call that B, we'll call that C for the sake of it. So it will be, let's try and remember cosine rule, let's write it down. So the length is b squared plus c squared minus 2bc cosine the angle. So we can just stick the numbers in, I guess. So a to b, the length is root 10, and then we're squaring it, plus b squared, which is O to a, which is root 2 squared, plus 2 root 5 squared, minus 2 times these two lengths here, so that's going to be minus 2 times root 2 times 2 root 5 times by cosine of the angle. Now, if you weren't so confident with this, you could just stick the entire thing in your calculator and be done with it. So that's exactly what I'm going to do, because I'm being lazy. What's the best thing to do? It's going to be root 2. And yes, I'm going to stick the entire thing in the calculator because I'm being lazy. So I'll make sure to make an error for you guys. Minus the root 10 squared over this thing, which was 2 times root 2 times by 2 square root 5. What's that going to be? And then we do the inverse cosine of that, and we still get 18.4. I'll just the answer is 18.4 degrees, and that is to Now, for the mathematicians out there, you will have, of course, a different method of doing this. You'll have something called the dot product. Now, AL Maths can use this, there's nothing wrong in that, and it's a similar idea to what we've just done here with position vectors, but you can just find the dot product of these vectors, divide by each of the moduli and you're away. So the dot product of this is going to be 3 and then 4, so it's going to be a 7, divided by the modulus of each, so divided by root 2, and then this thing here is 2 root 5. So if we wanted to do that, for example, you should get the same answer out. Divide by root 2 times by 2 root 5. Hopefully yeah, that eventually does drop out. It's one of those where sorry, that should be a 6. No mistake, that should be a 6. That's better. You still get 18.4. So, for the mathematicians out there who are doing A-level maths, there's nothing wrong in you using the dot product, but if you're not, then you will have to go ahead and use the cosine rule. That's the end of the video.